Now let's work on some break-even analysis problems. I think that will be helpful to your homework. Now let's get started. The problem A asks us to calculate the initial capital investment such that alternative 2 will be better than alternative 1. Since most of the terms are in annual cash flows, so I'm going to use the annual worth method to calculate both for alternative 1 and alternative 2. To solve this problem, we can set the annual worth of alternative 1 and alternative 2 equal and set the initial capital investment for alternative 2 as unknown, and we can use this equation to find the unknown capital investment for alternative 2. So now let's look at the annual worth of alternative 1. And we just go through the terms in the table one by one. So we have the first term as the capital investment, and we want to change that to the annual worth. So gonna use the annuity formula. So in this context, I'm using the negative values for the cost. So I'm put negative sign here and transfer this one back to the annuity. So P given A, it's A given P. And the hurdle rate, which is 15%, and that's useful life, 8 years. And the annual revenue, we don't need to do anything here. And the annual expense, that's minus 400, since it's annual worth already, we don't need to do anything here. And the next one is also the last one would be the market value. So that's what we're gonna receive for alternative 1. So it's positive value and it's plus 800, and I'm gonna change that to the annual worth. So A given F, we have 15% in 8 years, and this number would be 255. So for alternative 2, even though the problem implies that the alternative 2 will be inferior to alternative 1, given this capital investment in this table, but we still want to check it first. So let me show the work first. So annual worth of alternative 2, that equals the capital investment minus 6,000, and transfer that to the annual worth. So A given P, 15% in 10 years. And we have the annual revenue plus 1,850, and minus the annual expenses 500. Since already annual worth, we don't need to change anything. And then the market value, that's positive, and that's A given F, and the hurdle rate for 10 years. Then we will have this guy equals, so let me first plug in the factor numbers first, and then calculate the final solution for annual worth of alternative 2, because we're going to use that again to get the unknown capital investment such that alternative 2 will be better than alternative 1. So minus 6,000 times, that's 0.1993 plus, so these together would be 1350, and the last piece, that's 1,200 times 0.0493, and we will get this number, that's 213, and that's exactly less than the 255, which is the annual worth of alternative 1. Now we know alternative 2 is inferior, and then now we want to find the capital investment such that alternative 2 the annual worth of alternative 2 will equal to alternative 1. And so what is I for alternative 2? So we're gonna still borrow this formulation above for the alternative 2. So we still have this formulation, but instead of using the minus 6,000, we're gonna assume we have some unknown capital investment for alternative 2, and then A given P, 15%, 10 years, plus 1850 minus 500, and plus that market value back to the new annual worth, and 15%, 10. Okay, then this guy will equal the annual worth of alternative 1, which would be 255. And after plugging these numbers, we can get that's I times 0.1993 plus 1350 plus 100.0493 equals 255. And it's just one variable, one unknown equation, and very straightforwardly we can get I equals 5791. So this means when we have the initial capital investment for alternative 2 equals this number, and this annual worth of alternative 1 will equal to alternative 2. And if we want to let the annual worth of 2 greater than the annual worth of alternative 1, obviously the capital investment of alternative 2 should be less than or equal to the number we have above, 5,791. But you also can try another way to set up this problem to get this inequality directly. So you still use the formulation. Let me just call this formulation above here is the annual worth 2. So we can use annual worth 2, and since we want a better alternative 2, so we set that annual worth 2 greater than or equal to the annual worth of alternative 1, which equals 255, and we will still get this conclusion that the I will be less than or equal to 5791. And we are done for problem A. Now problem B asks us to determine the lifetime of the alternative 1 such we have the equal annual worth for both alternatives. So we're still setting an equation for that. So annual worth of 1 equals annual worth of 2. But here now the number of years for alternative 1 will be the unknown. And from the setup we have already used in the problem A, so we're going to just borrow the formulation. So now we have minus 4,500 times the factor A given P, the hurdle rate 50%. But remember we have the unknown lifetime years for A, alternative 1. So now we put big N here. And we have the annual revenue and the annual expense, 400, and the market value. So A given F, 15%, and we don't know, I want to know the life years, so put that big N there, and this equation will equal to the annual worth of 2, that which would be 213. To get the number n, we may want to. There are maybe two ways. First way, you can use the appendix and try an error by plugging those numbers with the years you can test. And the second way, and this will be the one I want to introduce the next, so use the mathematical formulation for those factors. Now we just plug in the mathematical formulation for the factors, then we will have, that's minus 4,500 times, so this factor will be 0.515 times 1 plus 0.15 to the power of n, and we have 1 plus 15 to the power of n minus 1 plus 1 1200 plus 100 times, so a given f would be 0.15 times 1 plus 15 to the power of n minus 1, and this guy equals to 113. And we can just do some algebra, multiply the denominator to both sides of the equation, and then we probably will get some known number like a times 1.15 to the power of n equals some number of b, and then we will have this guy equals b divided by a, and we take the log on both sides. We will have n log 1.15 equals log b divided by a. So we will have n equal to log b divided by a divided by log 1.15. So I don't write out the specific numbers for the b and a, but you should get these numbers for yourself very easily. And this n will be probably around 7.3 years. And we are done for problem B.